Let's see how many of you here are GlobalProtect customers. And how many among you have enabled GlobalProtect in an always-on mode with split tunnel disable? No one? Okay. All right. This is Siva, Technical Marketing Engineer for GlobalProtect, and I'm joined here by Warby, who's a Technical Marketing Manager, and both of us are from Palo Alto Networks. In this session, we are going to talk about how do you secure the internet traffic from your mobile workforce, and how do you do that in a scalable way, and at the same time, not adding to the latency that the end user would experience when he's accessing the internet over the tunnel. First, let's look at your current deployment. You have deployed our next-gen security platform on your perimeter of your corporate network. And this firewall sitting on the perimeter has visibility into all the traffic that goes in and out of your corporate network. And since this firewall is sitting on the perimeter, it can inspect the traffic for user ID, for app ID, and content, and hence it is able to protect the user and their device as long as they're inside your corporate network. But when these users leave the network, they can access internet directly, meaning the traffic from these users' machine when they are remote does not go through your perimeter firewall anymore, and they no longer have the protection they had when they were inside your corporate network. And what that means is these users are now exposed to different kinds of threats: internet threats, SaaS threats, and identity threats. And they can get their machines infected by malwares and botnets, and the users can also be tricked into clicking on phishing URLs, meaning they can lose their identity credentials to an attacker. When these machines get infected and these machines come back into your network at a later point of time, they infect other machines, other users' machines in your corporate network. Even though you have a perimeter firewall protecting your corporate network, because these users are valid users and valid employees who were able to get back into the corporate with an infected machine, they infected other users' machines in your network. And remember, if you haven't segmented your network properly, you are also carrying a risk of infecting your servers in your network, and even the entire data center can get infected. So always remember to do internal network segmentation properly so that you reduce the attack surface. Clearly, securing the perimeter of your corporate network is not enough. You need something more than this. So what is the solution? The solution is, if you have been listening to our sessions the last 2 days, GlobalProtect is the answer to this. GlobalProtect is our next-gen security, provides the extension and the security that the next-gen security platform provides to where the end user is. And GlobalProtect does this by establishing a VPN tunnel back to your perimeter firewall. And what that means is the traffic from the end user's machine now is tunneled back to your perimeter firewall, and your perimeter firewall now has the visibility into the traffic even when the user is not inside your network. And that is how the firewall sees the traffic, and that is how the firewall would be able to provide the same level of protection to the user even when the user is not inside your corporate network. Now, if you want this firewall to protect all the traffic from this user, and if you want to make this protection all the time, you must deploy GlobalProtect in an always-on mode, and you must also disable split tunneling. When we started the session, I checked to see if you have deployed GlobalProtect. You said yes, but I did not see anybody who has deployed GlobalProtect in an always-on mode, and there was nobody who has deployed GlobalProtect with split tunnel disabled. Both of these are really, really important, because only in an always-on mode you would see that the user is always protected all the time. We want the firewall to see the traffic all the time, and we want the firewall to have visibility into all the traffic, meaning split tunnel should be disabled. What we are protecting here is protecting the user when he is accessing the internet from all these malwares and botnets. So you must be enabling GlobalProtect in an always-on mode with split tunnel disabled. Now, all of you would agree to this from a security standpoint, but the questions that you might have are more from a usability standpoint. The questions that you might have in your mind now are, okay, I'm okay to tunnel all the traffic to my perimeter firewall, but wouldn't that cause a lot of latency issues to my end user? Wouldn't my end user start feeling that when he's accessing Netflix and YouTube, there's a lot of delay? These are valid questions. And what do you do about it? This is when we want you to start deploying gateways as close as possible to where the user is. So if you have user population in the US and if you have a substantial number of users in the UK, we want you to deploy at least 2 gateways, one in the US and one in the UK. Deploy gateways as close as possible to where the user is. The next question that you might have in your mind is, I have my user population distributed across the globe, and I do not have data centers in every region, so what do I do? This is when we want you to consider deploying our GlobalProtect gateway in the public cloud. Deploying a VM series firewall in public cloud is supported on Amazon Web Services, and we also have support for deploying VM series on Microsoft Azure today. With the release of PanoOS 7.1, you can deploy VM series on Microsoft Azure as well. So what does that achieve by deploying a VM series firewall in the public cloud? Let's assume a scenario where there are a number of users in California, and what I would want to do for these users is I would deploy a gateway in AWS in NorCal region, and all the users in California would get connected to this VM series firewall. And when I am a user in California, I'm getting connected to this gateway in NorCal region. All my traffic is tunneled through this gateway, and this firewall, since it's VM series firewall, next-gen security platform on public cloud, it can inspect all my internet traffic for user ID, app ID, and content, and it would be able to protect me and my device when I am connected here. So this is what happens. The traffic from the user's machine goes to the VM series firewall, and any traffic to the internet goes out directly from the VM series to the internet. And similarly, a user in Virginia gets connected to a gateway in Virginia. And this is again a region in AWS that you can deploy a VM series there. And all the internet traffic from these users in Virginia get routed through this tunnel into the VM series gateway, and traffic out from VM series goes directly into the internet. There are 2 things that have happened here. One, you have deployed a gateway and you have got all the users getting connected to the gateway through the VPN tunnel, meaning you are securing your remote users wherever they are. You are continuing to able to extend the security and the protection offered by our next-gen security platform even when the users are not in your corporate network. And 2, since you have deployed a gateway as close as possible to where the user is, you are taking care of the latency issues.
How do you get the user ID information talk back to the data center?
Yeah, so this particular the question is, how do I get my user ID? So as you know, GlobalProtect is the reliable way of getting user ID, and in this case, this particular VM series firewall, the one that is shown on the slide here, is particularly securing the internet traffic only. And we'll talk about in the next slide, how do you get your data center access for these users. All right. So the next question like he asked is, now I got my users connected to a VM series firewall and I have secured the internet traffic. Now how do I provide access to these users who are connected to VM series to access my data center? The answer is, you must deploy a site-to-site VPN tunnel between your VM series firewall and your perimeter firewall. This is a site-to-site tunnel using LSVPN. And once you establish this tunnel, what happens is a user in California here is continuing to access just the internet. So he is connected to a VM series gateway, tunneling all the traffic to this VM series firewall, which continues to protect the user by inspecting for user ID, app ID, and content. And the traffic goes out to the internet directly. Now a user in Virginia, he wants to access the data center. So this is what happens. The traffic to the corporate goes through the site-to-site tunnel back to the corporate network. And in this case, the user ID, because the user had authenticated to the Virginia gateway in AWS, the user ID is available in the gateway in the VM series firewall in Virginia. And because of user ID redistribution, you would be able to distribute the user ID to your corporate firewall, corporate perimeter firewall. And when the user goes internal to the network, you would be able to authenticate to internal gateways, and all of your internal gateways will have your user ID. All right. So the next thing I wanted to show you is two quick demos. The first demo would be about the end user experience when the user connects to a firewall on the public cloud. And the second one is I would show you the how you can use Panorama to manage your gateways. This is a user in California who's logging into his Windows machine. And as you could see, as soon as the user logged into the Windows machine, VPN tunnel got set up. One, always on has been enabled. That's why as soon as the user logged in, VPN tunnel got established. So all the traffic is going through the tunnel now. And you could see that the user is now connected to a gateway in NorCal in Amazon Web Services. There are a bunch of gateways here, but the user got connected to a gateway closer to him. Remember, this is a user in California trying to log in. And if you quickly do a rediscover network, I'm just trying to mimic a scenario where the user is going out and coming back into the network. Tunnel got re-established, and the user got connected to the NorCal gateway. The selection of gateway or the best gateway to which the user has to connect to depends on SSL response time and the priority that you configure. I can talk more about it if you have time. Stop by and I can talk more about it. Sorry? In this scenario, the portal is not on AWS, but you could have portal also in AWS. That is possible. Where is the portal? The portal is in the data center. Yes. In the demo that I am showing you now, the portal is in the data center, and if you want, the portal can be anywhere. It can be on AWS as well. There is no restriction on where the portal needs to be. As long as the users can reach the portal and download the client config, that is good enough. And while we talk, what had happened is the user is still connected to Amazon Web Services gateway. And since there is a site-to-site tunnel back from AWS VM series firewall to my perimeter firewall, I was able to access a resource in the corporate. That's the end user experience when he's connected to a VM series firewall. So even though a user is connected to a gateway in AWS, because there is a site-to-site tunnel back to my perimeter firewall, I am able to access a resource inside my corporate network. All right. The next video that I want to show you is how to use Panorama for all of this. And why would you want to use Panorama for all of this? If you have been following me along, you would be deploying gateways as close as possible to where the user is, meaning you would have deployed multiple gateways all across the globe. And that means the next question that you would have in your mind is, how do I make sure all my gateways are configured correctly? How do I make sure all of these gateways have the same policies and so that they can provide consistent security enforcement for all the users irrespective of where they are getting connected to? The answer is Panorama. Now let's look at this video where I show you by logging into Panorama. So I log into Panorama. This Panorama manages all of my firewalls that I got in AWS. There are about 8 to 9 firewalls that I've deployed in AWS, and all of these are being managed from one central Panorama. There's one screen where you can actually see the status of their connection to Panorama, and you could also find out if the configuration that they have on the firewall is in sync with what I have configured on my Panorama or not, all in one screen. And where would you begin? You would begin with configuring templates and device groups. Templates are a configuration that includes your network and device configurations. And what would you have in your template? You would include your configuration for your GlobalProtect gateway, since these are GlobalProtect gateways. And you would also have information about your IPsec VPN. So device groups would include your policies, your security policies, your NAT policies, and it also includes your HIP objects that if you are using HIP in security policy enforcement, it would include all of that. Now let's look at a template here. There's a template that I have, which is GlobalProtect AWS template. And the configuration that I got in there is one of the gateways. And this configuration says my gateway is turned on Ethernet 1/1. And if you notice clearly here, the IP address, I'm using an address object. I'm not giving in an IP address here, but an address object, so that I can use one template for all of my firewalls in AWS. And the translation of that address object into an IP address happens on the device when the configuration has been pushed. The next thing you would need on this firewall is a site-to-site tunnel from your AWS firewall to your perimeter firewall. And there's just simple configuration that is required to be done on this firewall. All you got to do is provide a portal address, and this is the portal to which this satellite or this VM series firewall would first connect and authenticate with, and it would download a satellite configuration. The satellite configuration will include all of the gateways to which this particular VM series firewall should establish VPN tunnel with. And once the site-to-site tunnel has been established, this would form a way for the user to get access to the corporate network. Now, you've deployed your firewall, you have configured it. You might ask me, like, how do I make sure all my firewalls are running a certain version? How do I upgrade them all? Do I have to upgrade them manually? You don't have to. You go to Panorama, you select the software that you want to install, select all the managed devices that you got, and you push down the software to these devices. And that's all you need to do. So where do I want to leave you with? If you want to secure the internet traffic from all of your mobile workforce, you would want to deploy GlobalProtect. And you would want to deploy GlobalProtect in an always-on mode with split tunnel disabled. That's the only way the firewall can see all the traffic from your end user, irrespective of where they are. And to answer your latency questions, to answer the user's experience and all of that, you would want to deploy a gateway as close as possible to where the user is. And in cases where you do not have a data center presence in a particular region, but you have a lot of users connecting from there, you would consider deploying a VM series firewall in public cloud. You can use Microsoft Azure starting 7.1 or AWS. And to manage all of your gateways, you would use Panorama to do that. With that, I would hand over to Warby, who would help you with the auto-scaling part of it. I can take the questions later, if it's okay. Yeah. Thank you, Warby.
Thank you, Siva. So my name's Warby. I'm going to talk about, so we talked about the advantages of getting onto public cloud, AWS, Azure, and also vCloud Air, we support as well. And by having a more distributed deployment of gateways, it's a better user experience, and it doesn't get in the way. We actually deployed this internally. The demo that he was using, I've been using for over a year for my every day-to-day work. That entire deployment worldwide took 4 hours to create. No hardware shipping, no customs, no staging. 4 hours start to finish, a global GlobalProtect solution that I've been using, like I say, for over years. A lot of us internally have been beta testing for that long, and it's great. It's out of the way. I don't even know it's on. I'll be doing a demo of something else, and then someone will ask me about GlobalProtect, and I say, oh yeah, we've been actually doing that this whole time. And I didn't even realize, I just don't notice it anymore. So the question is, I'm rolling it out in the public cloud, but what about performance? What about scale? We want to be able to use the VM series at scale in the cloud. We started originally on ESXi was our first hypervisor, and we literally took code from a piece of hardware, one of our hardware firewalls, modified drivers to run in ESXi originally. We've added a lot more hypervisors, but it's still the same code. So when you saw a new feature announced yesterday in Lee's session, they work across all our platforms. App ID, user ID, all of those things work in the VM series. And they're all managed by Panorama. It wasn't a separate project. It wasn't an acquisition. It's the same code. So this is a dashboard and device tab of a firewall. And this is a dashboard and device tab of another firewall. One of these is a VM series. The other one is a 7K. At a glance, it's hard to tell. We actually migrated our demo systems from physical firewalls in colos to AWS virtual firewalls. Some of the SEs didn't notice at first that they were on a virtual firewall. That's how similar it is. Same web UI, CLI, API. Specifically for AWS, it's the same platform in on-demand environment. So we get visibility in the cloud, whether it's GlobalProtect or another use case. We can do inter-subnet, inter-VPC, or truly internet-based traffic protection, known and unknown, just like all of our platforms. And again, all of this centrally managed, centrally logged if you choose. AWS talks about a shared security model, and if you were in my other session, we talked about this. And it's basically a model where AWS is responsible for securing the foundation. They expect customers to be responsible for securing their content. So the VM series firewall fits on the top. There are security services built into AWS, things like security groups, ACLs, even web application firewalls. We complement that. You can't get things like Wildfire or App ID or User ID with the built-in services, but there's services that they also need to own and manage and secure. So we work together. And if you were in the earlier sessions with AWS, we both talked about that. Specifically in AWS, we have a BYOL model. And as Lee mentioned yesterday, that BYOL license is portable. You can purchase that license, you own it, you can deploy it in AWS, you can deactivate it and deploy it in ESXi, deactivate it, deploy it in Azure. You own that. You don't have to worry about, well, I'm done in that environment, now I've lost that money. For shorter term projects or for auto scaling, it might make sense to do a usage-based licensing model. And we have those that are hourly or annual. And those are based on which subscriptions you get in the bundle. We have 2 bundles. If you go to the AWS Marketplace, search for Palo Alto Networks firewalls, you'll see the 3, the BYOL Bundle 1. Bundle 2 includes all the subscriptions. So when you run one of the bundles, you're going to get a bill for the EC2 usage and then another portion for the licensing costs. And when you deactivate that firewall or even shut it down, the licensing costs stop. So it's only while it's running. BYOL is permanently yours. Bundles are only when it's in use. So here's kind of another view of the GlobalProtect use case. So this one shows a couple gateways. With the Amazon footprint, you could even supplement it with other clouds if you choose. You don't have to just use one cloud because there are gateways running in the cloud. It's, as far as the GlobalProtect agent and Panorama are concerned, it doesn't matter where it's actually running. But you can get rid of your colos. And that's what we're doing internally because of our success at doing this. So the next question is, what about scaling? In AWS, there's auto-scaling components like auto-scaling groups, which are groups of instances that can be added or removed on demand. CloudWatch is the component that collects the metrics to make the decision about when to do an auto-scaling event. The simple queuing service is the service that actually queues up the event so that other services around it can take action. And then the security controller. Prior to 7.1, we didn't have bootstrapping. And we used what AWS calls a worker node. We call the security controller, which actually will collect custom metrics from PanOS, like numbers of sessions or users in GlobalProtect, publish them to CloudWatch, and then also use an Ansible playbook to configure the firewall. The configuration can now be replaced with bootstrapping in 7.1. So the demo I'm going to show you is built on 7.0, but we're going to have a new version that actually takes advantage of bootstrapping. So I'm going to show you a demo of all these components working. So yeah. Yeah, so there's actually, I don't know what they're going to do with this content, but there's a Lightboard video on our YouTube channel of the demo I'm about to show you with a Lightboard introduction of me doing goofy drawing beforehand. But the video portion is identical to what you're about to see. Yeah, search for, on our YouTube channel, search for auto scaling on AWS and you should get to it. So this is kind of what it looks like. Within a VPC in AWS, you have 2 availability zones for redundancy. So you initially start with 2 firewalls. And you've got the tunnels back to corporate. So the firewalls on top are meant to represent the corporate data center. So let's say there's a spike in demand on those gateways. Maybe there's a snowstorm and a lot of employees are suddenly working at home on the East Coast. It would be nice if completely automatic new gateways spun up to handle that increase in load. Equally as importantly, when the demand drops off, I don't want to have to pay for those anymore. They should be removed as well. So end of the day, the snowstorm is, they've cleared the roads. We don't need those gateways anymore. So let's scale back down to just maybe 2 for redundancy, or even down to 1. So these are all the components. The security controller is in the center. We have the portal. The auto scaling group is for the gateway on the left. And we can see the CloudWatch and SQS services. And the first thing we need to do is we need to know what's the current state of that gateway. We need to collect metrics to see how busy it is. So the security controller is going to use our API to collect those metrics.
Is auto scaling, is it transparent to Panorama or it's
Let me get back to the questions because this is going to keep running. So this is what it looks like initially in the console. We have the gateway, the portal, and the security controller. And this is what the portal looks like. And initially, we just have the one gateway. So this is the initial state. I set the auto scaling group minimum to 1. And in this case, the gateways are named based on the AWS IDs that we get. So I've got it. Now I need to collect the metrics and use the API, and then use the AWS API to push those metrics to CloudWatch as custom metrics. So if we go over here to CloudWatch, we now have custom PAN-OS metrics in addition to the EC2 metrics that are built in, things like memory and RAM, or in compute. And we can look at historical data, a few days of data, and we can see the spikes that we've simulated. So the scale is on the left. So the active sessions, we had some spikes, and so those were prior events. And now we're going to show an actual event in real time here. So I'm pushing metrics. I'm going to create a spike in demand on that gateway. So we go back to CloudWatch, return to the graph. So the scale is about 25 on the left. We're going to do a refresh here. We have an alarm. If we refresh the graph, the scale is up to 100. So we've simulated lots of users connecting, and we've created an alarm in CloudWatch. And if we come over here to the auto scaling view, we can see there's a new event. So we're launching a new firewall in this case. And auto scaling is very configurable. You can be very conservative. You can be very liberal. So at this point, auto scaling, based on the alarm from CloudWatch, is kicking off a new firewall. So if we return to our console view in AWS, we should see a new firewall coming up. So we had 3 running instances at the beginning of this. We now have 4. And so there's our new firewall. And the ID ends in 343, and it's initializing. So it's booting up. Now, since this is prior to 7.1 when this was built, we need a way to configure that outside of bootstrapping. So we're going to send the event to SQS, which is being monitored by the security controller. And it now knows there's a new gateway that needs a configuration. And so using our API, it's going to configure that firewall. And again, that will be replaced by bootstrapping. It's also going to tell the portal, here's a new gateway. Let your users know when they start connecting about this new gateway. If we go back to the portal config, there's that 343 that just showed up. So it's already registered in the portal. I haven't done anything at this point. All I did was create a bunch of traffic, and all these things are automated. So the clients have a lower cache on their portal. They do more frequent refreshes automatically. They learn about the new gateways. And because it's going to have a faster response time, they're going to automatically start using it. And so in the client view, on the agent itself, if we do a rediscover just to not have to wait for the cache timeout, even faster, we should see the new gateway. Again, it ended in 343. So that's the one it connected to, and then on the bottom is the new one. So all this is built, it works, it's running. The deployment itself is still fairly manual. We're actually working on a project to create a CloudFormation template that you can use to launch the entire deployment for your own environment, to test it, try it out, and even modify it for your own use. So if you're interested in playing with this right away, you can work with me and I'll help you deploy it. But in the near future, in a few weeks, I hope to actually have a template with a deployment guide where you can do this entire thing on your own environment. So you had a question?
Yeah, so this is all transparent with Panorama, but Panorama doesn't get involved in auto scaling.
So the question is, does Panorama get involved in auto scaling? And it does not, but the gateways themselves, if you're using Panorama, you could use that either bootstrapping or the security controller to also tell Panorama, here's a new firewall. So maybe the initial config on that new gateway is very minimal to talk on the network and how to talk to Panorama. And now it can actually use bootstrapping in 7.1 to register to Panorama so Panorama can push the entire config, including the policy, which makes managing that config much simpler if you're using Panorama. So Panorama is the way to go in this environment, because now if you need to make a change in policy, you don't have to change a playbook in Ansible or a bootstrap file. You change it in Panorama. All the existing and all the future gateways automatically get that config change. Yeah. So actually, can we get microphones? I guess they want to record this, and so they want the audio.
Utilization, if we were to add GlobalProtect to our 3000 series overseas, so 10 to 100 users, how much of an impact would that have for memory, CPU?
You want to take a stab at that one? Did you hear the question?
No, I could not. Sir, can you repeat the question, please?
So adding GlobalProtect to our 3000 series firewalls that we have overseas, if we have 10 to 100 users, how much of an impact is that going to have on CPU and memory?
So yeah, the question is, I think everybody heard the question. So the impact on the CPU and memory, it depends on other features that you turn on your firewall as well. So if it is going to act as a purely GlobalProtect gateway only, then the impact is going to be a lot more lesser. But you would normally be turning on app ID and content and threads and all of that on the firewall. So if you go to our compare firewalls that is available on Palo Alto Networks website, you will be able to see some of the metrics that we have covered in the data sheet that are available there. I don't believe we have the CPU and the memory numbers on that sheet, but depending on your traffic, depending on how much the firewall is going to handle, the throughput and the CPU and memory would all
So the impact would be more based on the features that you turn on, not the fact that it's running GlobalProtect.
Correct, and the traffic that you are sending through it.
Okay.
Actually, I have a question regarding AWS on bootstrapping.
Yep.
Are we able to take a snapshot and dump that snapshot to S3 bucket and able to call it and just scale out that way rather than bootstrapping every firewall that we are trying to scale?
So the best way to do it is to you bring up the firewall, you can export a bootstrap structure from that, and then absolutely it should be an S3 bucket. That's how it's supported in AWS. And then every new firewall, GlobalProtect or not, right? This works in other use cases as well. We'll reference that S3 bucket using what AWS calls a user data field, and it will pull that in. Ideally, it would be just pulling in minimal information like maybe licensing if it's BYOL and Panorama, but you could do the entire config that way. But yeah, it would be one bootstrap file shared among multiple firewalls.
We have a question right here too.
What happens when auto-scaling scales down? What happens to the clients? Do they just get disconnected?
So there's a few options there. You can just literally delete that firewall. The agent will detect that it's happened, rescan the remaining gateways, and reconnect. Depending on the application that the user is using at the time that happens, they may not notice it at all, or it may be disruptive. You can do things like session draining, be more graceful. You could configure the security controller to remove it from the portal so new users don't come. Set a low timeout on the actual GlobalProtect session. Wait for that maybe an hour or two, whatever you want. So it depends on how quickly you want to start saving money and how conservative you want to be about disrupting the user. But you have the flexibility.
Okay, thank you. I have one more question.
Sure.
Are there gotchas or is it supported in AWS GovCloud?
So generally speaking, AWS GovCloud is a whole nother beast. Come up and talk to me about that. GlobalProtect or not, there's tricks there. It's a little bit different. There's not a traditional marketplace, so it's a little bit different doing deployments, which it sounds like you're familiar with. Question up here?
Here you go.
Thank you. So if we're doing different policies for whether corporate laptops or users from home, would we set up different gateways for those different policies if we're using cert-based auth for our laptops, but Entrust and AD for users at home?
Yeah, so I think if you want to differentiate the corporate issued images and your personal devices, it all depends on what you wanted to provide. So it starts with what type of authentication you wanted to have. So definitely a machine which is a corporate issued machine would have a certificate on it. You would have somehow figured out how to distribute the certificate. And in that case, you could require certificate auth on those machines. And a personal device obviously would not have a certificate, so you would not be able to do that. So depending on what authentication method that you wanted to require for these machines, you would try to design your implementation around that. So if you have a portal, and if portal is going to authenticate users based on your Active Directory credentials only, so the user authenticates using Active Directory credentials, downloads the client config, and that's all the portal does, distribute the client config to all the endpoints. Once it is available on the endpoint, you have multiple gateways, and you could have, based on where the machine is coming from, you could actually say that the user is going to connect to a particular gateway, and you can have differentiated authentication for each of the gateways. You can have certain gateways which would require you to authenticate, step up and authenticate using certificate as an additional factor, or you could do a one-time password authentication. Those gateways would be the ones a corporate machine would be connecting to, and then so that they can access additional sensitive resources. Otherwise, all of them would have access to only general purpose resource.
Could you also combine the authentication methods on an individual gateway and then use user ID groups to determine what policy they get?
That's another thing that you could do. So in case if you have the same authentication method configured across all the gateways, but you wanted to differentiate whether they are a super user or an admin user, and then you want to differentiate, provide differentiated access based on what groups they belong to, you could do that. You could do that on the security policies itself, saying you could have a policy that says from this particular source zone to that destination zone, give access only to administrator groups, or give access only to folks within the engineering Active Directory group. You could do all of that.
Okay, we got a question here, and then we'll come over here.
So in order to configure the multiple gateways on the same device, you need a separate IP address.
That is correct.
Are there any challenges in AWS to get the second IP address for that? Because doesn't it automatically assign like a public IP?
So it's up to you whether it gets a public IP or not. That's configurable. And typically I would recommend using DHCP, the security controller. When it gets the message from the SQS of the ID, it can actually do an API call. It does do an API call to AWS to learn that IP, which was probably given by DHCP, so that you can use a common bootstrap for all of them. You don't have to have a different one or go back and modify the IP every time. You can actually just learn it and let it get its own dynamically. Yep.
So the IPsec between the gateway and the data center, is that going through the regular internet, or are you guys doing anything special with Amazon to put that traffic across the Amazon network?
You can do either one. You could use AWS Direct Connect, where you actually get a fiber into a separate cage with your own terminating device, and then a cross connect, which goes out to the other building where their data center is, where you can have control over the bandwidth and you can get substantially more bandwidth. Or you can do it purely over the internet. Our deployment is over the internet. AWS connectivity to the internet is very good. You probably won't be able to beat it unless you're really going up towards 10 gig or more. But it's substantial.
And that sort of leads into a next question I have. What's the maximum performance you could get through that IPsec between the gateway and the end devices?
Back to corporate, you mean?
Yeah.
So for an individual, it depends on which instance type you use. Typically, you're not going to get above a gig, which is one of the things that you should be monitoring when you decide when you need more firewalls, not just purely users. It should be a combination of things like throughput, CPU, RAM, and sessions. And then you can configure CloudWatch thresholds based on combinations of those metrics. It's a very flexible and powerful tool.
On average, what's Palo Alto spending a month for this instantiation with AWS?
I think you have numbers, right?
Yep. In the demo, I showed about 9 gateways on AWS. So the collective cost so there are two different models in which you can actually deploy firewalls in AWS. And also we talked about the different licensing models that we got. So licensing model that you choose, and then the instance on AWS that you choose, all of that would determine how much is the cost. For us, for the 9 gateways that we have got, and for roughly about 130 gig of traffic that goes through all the gateways from about 50 to 100 users that we have who are beta testing this product now, the cost is around $250 to $350 a month for each of these gateways. But there is a different type of deployment that you could do on AWS, which is called the
Talking about the bundles?
the bundle, the collective thing which we did last.
Oh, yeah. So for areas where you know you'll always have one gateway, you can actually pre-purchase from AWS the usage cost for one or more instances. Within a region, it'll automatically apply that, even in an auto-scaling group. So you get a significant discount by pre-purchasing a year or 2 years in advance. So that's one way to bring it down. Purely from the instance usage costs of our instance, depending on which instance you choose, independent of licensing, it's about $150 for the AWS piece to leave like a C4 extra large running for a month 24/7. And then on top of that is licensing and the traffic itself.
Cost.
Yeah, and the deployment we have, we don't have the auto scaling added yet because we just built it. But we're absolutely going to add that because we do get, just like everybody, certain gateways get very busy, users get frustrated, and then they want to turn it off, right? Which is what we're trying to avoid here. Any more questions? Yeah.
Can I get you a mic?
Yeah, so I just have a question. If you have multiple...
They're recording. Can you, sorry, thank you.
So if you have multiple corporate sites,
Yep.
and you have your gateway in AWS, can you put like route statements to go to different corporate sites?
Absolutely. So you would have tunnels to each of the corporate sites, and then you would have routing for, hopefully you can easily articulate all the corporate address space in one versus another. And then when the users connect, it's pure BGP, OSPF, whatever you're using to get to the correct tunnel. Absolutely. Question here?
Yeah, just one question. We'd looked at always-on tunnels from different vendors before, and our clients always said that the batteries ran down faster on their mobile devices. Have you done any testing in that environment to see how that would run down their battery, what their battery life would be?
Most of us who have been using the GP beta instance, all of the GP beta instance that I showed you in a demo has been configured for always-on mode. So I have it running on my phone, I have it running on my laptop, and even Warby does that. So we haven't seen a significant drop in battery because I'm connected to VPN all the time. So I know that the numbers from other VPN vendors where the battery drains off quickly, but with GlobalProtect, we haven't seen that happen. You should definitely try that out because our recommendation has always been enable always on VPN with split tunnel disable. So we have done our testing to make sure the battery doesn't drain.
We got like 1 minute left. Any last minute questions? We'll stick around till they kick us out if people want to come and ask questions as well.
Thank you.
Thank you very much.